Using the quadratic formula. Learning intention. Solve quadratic equations using the quadratic formula. Success criteria. I can identify A, B, and C, substitute into the quadratic formula correctly, calculate the discriminant, find both solutions using plus and minus, round answers to 2 decimal places. In the previous sections of this chapter, we used factors to solve quadratic equations of the form ax squared plus bx plus c is equal to 0. If the expression ax squared plus bx plus c cannot be factorized, the equation can be solved by using the quadratic formula which is given below. The quadratic formula. The roots of the quadratic equation ax squared plus bx plus c is equal to 0 are x is equal to minus b plus minus root b squared minus 4ac all over 2a. Example 1. Solve the following equations using the formula x is equal to minus b plus minus root b squared minus 4ac all over 2a. Give your answers correct to 2 decimal places. Whenever you are asked to solve a quadratic and it tells you to do it correct to a number of decimal places, that should be a hint for you to use the minus b formula, because that should be a hint to you that it cannot be factorized. So, number 1, x squared plus 4x plus 2 is equal to 0. So I write out my equation. I draw in my invisible 1 in front of the x squared. I label a, b, and c. So a is equal to 1, b is equal to 4, and c is equal to 2. Note that you don't ever put any x's into the formula, only numbers. I write out my equation, or my formula. This is in the formula book. And then I'm going to write it out again, but I'm going to replace every letter with a set of empty brackets. The brackets are essential here. You will go wrong if you don't use brackets. I then start to substitute into the brackets. So I replace the b with 4 because b is equal to 4. I replace that b with 4 as well. I replace the a with 1 because a is equal to 1. I replace that c with 2 because c is equal to 2. And I replace the a with 1 because a is equal to 1. So I'm going to write it out again underneath, but this time I'm going to just have a plus. So notice here the plus minus is just a plus now, and I have that in red so it stands out. And then I'm going to write it out again over here with a minus instead. So it's the exact same thing on both sides. One has a plus and the other has a minus. Now you can literally stick this straight into the calculator if you want, and you will get x approximately equal to minus 0.59, correct to 2 decimal places. And then all you have to do is press the arrow button, the left arrow button, to go back and delete this plus and put in a minus instead. So you don't need to write the whole thing out again. And you'll get x is approximately equal to minus 3.41. So here are the roots of this equation. So these are the 2 places where the curve will cross the x-axis. These are the solutions of the equation. So just to show you again where those numbers came from. So I've highlighted in yellow there all the a's, which I replaced with 1. I've highlighted in blue the b's, which I replaced with 4. And the c, which becomes 2. Now, what you could have done otherwise, instead of putting the whole thing into the calculator, was you could have simplified first. So minus bracket 4 bracket is just minus 4. And then 4 squared is 16. And minus 4 times 1 times 2 is minus 8. And 2 times 1 is 2. And then 16 minus 8 is 8. So we end up getting 8 underneath the root. This is known as the discriminant. So if you work out what's underneath the root, you get what's known as the discriminant. Now we can't simplify anymore, so now we break it up into the plus part, which gives us, again, minus 0.59 as before. And then we break it down into the minus part. So we have plus here and minus here. And we get the same answer as before, minus 3.41. So it's good to know this method where you simplify first, because you'll have to do that for complex numbers chapter. So just to show you where everything came from. So I've highlighted in yellow. I replaced the A's with 1. I replaced the B's with 4 and the C with 2. So number 2 is x squared plus 6x plus 4 is equal to 0. So I want to solve this and I want my solutions correct to 2 decimal places. So I add in my invisible 1. I label A, B and C. So A is equal to 1, B is equal to 6 and C is equal to 4. Again, remember you don't ever put any x's into the quadratic formula. I write out the formula. I write it out again with brackets in place of all the letters. So I'm going to replace the A's with 1. I'm going to replace the B's with 6. And I'm going to replace the C with 4. So I wrote the exact same thing down here, just I have a plus into the calculator, minus 0.76. And then I have it with a minus, so you just have to press the back arrow and go back and change that plus for a minus. You don't need to write the whole thing out again. And I get approximately equal to minus 5.24. So here are the solutions of our equation, or the roots of our equation, where the curve crosses the x-axis. Or I could have simplified first. So minus bracket 6 bracket gives us minus 6. 6 squared is 36. Minus 4 by 1 by 4 is minus 16. And 2 by 1 is 2. Then 36 minus 16 is 20. And I can't simplify anymore. So break it down into one with a plus. And into the calculator, minus 6 plus root 20 all over 2. Again, gives me minus 0.76. And then I have the same thing, just this time now with a minus. And I get minus 5.24 as before. Example 2. Use the quadratic formula to find the roots of the equation x squared plus 5x, 7x minus 3 is equal to 0, correct to 2 decimal places. So this question is telling us to use the quadratic formula, but most likely in the Leaving Certificate State exam, it will not say that. But the hint for you to use the quadratic formula is if it asks for decimal places. It doesn't matter if it says 1 decimal place, 2 decimal places, 3 decimal places. It doesn't matter what it is. It typically is 2 decimal places. But if it asks for decimal places, it cannot be factorized and you must use the minus b formula. So if it asks you to find the roots of the equation, this means solve. Solve for x, find the solutions. So I label my equation ABC. I write out my formula. Replace all the letters with brackets. I'm going to replace the A's with 5. Replace the B's with 7. And replace the C with minus 3. I then write the exact same thing down, this time just with a plus. Into the calculator, 0.34. And then I have the exact same thing again, but this time with a minus. I have highlighted here in red where I've swapped the plus for a minus. You don't need to write it all out in the calculator again. Just press the back button and replace that plus with minus. And we get minus 1.74. So these are the roots of the equation, or the solutions of the equation. Or we could have simplified first. So minus bracket 7 bracket is minus 7. And then 7 squared is 49. Minus 4 by 5 by minus 3 is 60. And 2 by 5 is 10. And then 49 plus 60 is 109. And then we break it down to have the plus part. So minus 7 plus root 109 over 10 gives 0.34. And then we replace that plus with a minus. So minus 7 minus root 109 over 10, again, is minus approximately equal to minus 1.74. So these are the roots of our equation. These are the two places where the curve crosses the x-axis. Example 3. Express the following equations in the form ax squared plus bx plus c is equal to 0, and hence, which means using what you've just worked out, solve the equations giving your answers correct to one place of decimals. So we have 12 over x plus 2 minus 1 over x is equal to 2. So there's no mention here of the quadratic equation formula, and we don't see a quadratic equation, but it is actually a question involving using the quadratic equation formula. So what we're going to do is simplify this fraction. We're going to simplify the left-hand side, and then we're going to bring everything, we're going to cross multiply and then bring everything over to the left-hand side or the right-hand side. And what we will end up with is a quadratic trinomial. And then we will use the minus b formula. So I'm just writing out the equation. I'm replacing the 2 with 2 over 1 because we want a fraction on both sides. I then have to get a common denominator on the left. So I'm just going to stick the x plus 2 onto the x with a set of brackets around each of them. And then I'm going to bring down the 12, stick on an empty set of brackets. And x plus 2 will divide into x plus 2 times x, will divide into the common denominator. The x plus 2's will cancel, leaving us with x. So x goes into the brackets. Then I bring down the minus. And then I go again. So I bring down the 1, stick on an empty set of brackets. And then I'm going to say x divides into x plus 2 times x, and the x's will cancel, leaving us with x plus 2. So x plus 2 goes into the brackets. So hopefully you notice the pattern. It's like a zigzag. So we've got x plus 2 in blue on the left, then the right, then the left. And then we've got x in yellow on the right, then the left, then the right. And that's all equal to 2 over 1. So then we multiply out the brackets. 12 by x is 12x. Minus 1 by x is minus 1x. And minus 1 by 2 is minus 2. And that's all over. We're going to multiply again. X by x, x squared. 2 by x, 2x, equal to 2 over 1. Then we're going to simplify the top of the fraction. So 12x minus 1x is 11x, and everything else remains the same. So I've simplified as much as I can. Now I'm going to cross multiply. So I have x squared plus 2x times 2. So I have it over here with brackets around it. And do not forget your equals. And then it's going to be 11x minus 2 times 1. Again with brackets. So then we multiply out our brackets. 2 by x squared is 2x squared. 2 by 2x is plus 4x. And then we bring down the 11x minus 2 because we're multiplying by 1, and anything multiplied by 1 is just itself. Now, when we're trying to solve a linear equation, we usually do letters to the left, numbers to the right. But when we have a quadratic, we want to bring everything over to the one side and let it equal to 0. So we're going to bring everything over to the left-hand side. So the 11x comes over and becomes minus 11x, and the minus 2 comes over and becomes plus 2. And that is equal to 0. We then simplify. So 4x minus 11x gives us minus 7x. So we have 2x squared minus 7x plus 2 is equal to 0. So we've simplified as much as we can. Now remember, we wanted to solve the equation. So now we're going to have to use the minus b formula. So now solve using the minus b formula. So we have 2x squared minus 7x plus 2. We label a, b, c. Write out the formula. Write out the formula with brackets in place of all the letters. We're going to replace the a's with 2. Replace the b's with minus 7. Replace the c with 2. So I'm going to have the exact same thing written down underneath here. Just instead of the plus minus, I've got plus. Into the calculator, I get 3.2 to 1 decimal place. And then I press back on my calculator and I replace that plus with a minus. No need to write the whole thing out again. And I get 0.3 to 1 decimal place. Or I could have simplified first. So minus bracket minus 7 is positive 7. So minus by minus is a plus. Minus 7 squared is 49. Be very careful here. You must use brackets. If you didn't have brackets here, you would have squared the 7 and then stuck on the minus, and it would have been wrong, and it would have given you an error in your calculator. So you have to use brackets. And then minus 4 by 2 by 2 is minus 16, and 2 by 2 is 4. Then 49 minus 16 is 33. So we break it down to a plus, and we get 3.2, and then we have the minus, and we get 0.3.